Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we are starting another sum of virtual work method or unit load method or Castigliano method. In previous we have done with the straight lines. Now we are solving this sum, question number 4, to inclined line. Inclined also come in the exam. While seeing the question, don't be confused. In inclined there is very simple concept over here. Let's see that concept and details. Now see students, this is a question given over here. In exam, while you see this inclined straight line, you will get confused. No need to confused in this inclined part because this inclined part is very simple. They have only one logic to apply over here. And what is that one logic? I will explain you over here only. Okay. Now see, this is a question given in the exam using unit load method or Castigliano theorem for rigid jointed frame shown in figure. Calculate a horizontal displacement of roller support at D. We have to find the roller support. We have to find 1 kilonewton over here. Okay. And take EI will be constant. Means if in exam there have no given the value of EI, you should keep the answer in terms of EI only. Okay. Your answer will be example like this 1.133 upon EI. Okay. Now for our first step will be draw the FBD of that part. First draw one second diagram, then draw right reaction, then small m diagram. After that we have to form the table, then apply the formula and then find the deflection at D. Now let's start with the first one. Now see, this is your hinge support, so it will come two reactions. This is your VA and see sorry. See, this is 25 is going in left to right direction. So as you all know, to symmetrical of that part, we have to do this will also come in this direction. This is your V. Since D is a roller support, only one reaction will come. This name as VD. Now see, this distance will be 5 meter. This is 4 meter, and this is 3 meter. Okay. Now after that, first step will be support reaction calculation. Now support reaction calculation, calculate first over here. Support reaction calculation. For support reaction calculation, as you all know, we are taking moment at A equal to 0, clockwise positive. Okay. Now what will come in the picture? See, we are taking moment over here. See, this 25 will going in the clockwise direction. So 25 into 5, then UDL also going in clockwise direction, so plus 30 into 4 into 4 by 2. Okay, this is a UDL force. This is a perpendicular distance. Now after that, what will come in the picture? Minus VD into this distance, 4 plus 3, it's 7, is equal to 0. While solving this, you get the value of VD. Your VD value will be 52.14 kilonewton in upward directions. Okay. After that, what we will do? After that, we have find summation Fy equal to 0, upward positive. Now see the diagram. What is going in the upward state? VA. We got the value of this is 52.14, and as you all know, VA is going up. So VA. Okay. Now see, this 30 will come in the downward direction. So minus 30 into 4. Now in y direction, no need to into the distance. As you all know, this is of only force of upward or downward. It means the sign conversion indicates that upward goes positive, downward goes negative. Okay. No need to into the distance. Distance will come only when m part is coming, like bending moment or moment. Okay. After that, plus 52.14 equal to 0. While solving this, you get the value of VA will be 67.86 kilonewton. Okay, this is a value of VA in upward direction. Put it over here, 67.86 kilonewton. Okay, now we're done with this three parts. To this 25 you can directly write, or you can solve over here. Summation fx equal to 0, this as positive. Now see this 20, this as unknowns. Example, this is HA minus HA plus 25 equal to 0, therefore HA will be 25 kilonewton. If you are taking sign conversion over here, this will come negative. If you are taking sign conversion over here, this will come positive. Means that your assumptions will be correct over here. Okay. Now after that, what is our next step? In our next step, we are taking release all the external loads and draw the diagram again for small m diagram. Okay. Now see, in this question we have to resolve this part. This is your main part in this question. Different in this previous question, this different part will be C and D. In CD part, what we have to do, we have to see this VA will be in the vertical direction. Okay, but we don't want vertical direction, because we are taking member CD will be inclined. So we want in CD member one force is towards the CD and one force is horizontal to the CD part. So for this we have to resolve that D part over here. Adjust this D part, zoom it over here. See, this D part will be zoom it over in the next page in detail, as you understand better. See, draw the diagram like this. This is your incline, this is your D part. Okay, this is your D part. Now in D part we know the value, this value will know. But in here we want this, don't want this vertical direction, we want towards the axial of this C and D, axial of C and D and vertical of C and D. What for this we have to resolve. Now how it will resolve? See, to resolve this part, extend all the members as much as possible like this. See, okay, now we have extend all these parts. Okay, now we want theta values. As you know, this value we know and this value also we know. Since see, this theta will come over here, this theta, and to find this theta, what formula we are applying? Tan theta is equal to opposite upon adjacent. This is your opposite side, this distance will be 5 meter, and this is your adjacent side, this distance will be 3 meter. So opposite upon adjacent means 5 upon 3. You get the value of theta over here, 59.03 degree. Okay, this is a theta value. So this theta, alternate thetas are same. Okay, now see, now we want over here axial of that CD part and vertical of that CD part. Now the axial of the CD part, what we are doing over here, see, this 14.54 kilonewton, move it in this line. This 14.54, sorry, 52.14, move it into. Now see students, we want this 52.14 move it into this direction. See, this direction will be in the axial of that CD. We want this value. Okay, now see, if you are this 52.4, put it over here. Say this is your vertical of part CD. Now we got the same, we got the value of as well as horizontal as well as vertical. Now after that, see, when we are 52.14, when you are moving from here to here, see, they have no angle. When there have no angle, the value will become 52.14 sine theta. Okay, when we are this 52.14 resolve over here, see, this is coming with respect to theta. See, this will coming with respect to theta, that's why 52.14 cos theta. Now this is your main value. Now we want this is your main value and this one is your main value. We want this two only over here. Okay. Now we got this value, we got this value. No, I don't want this value over here now. Okay, because when we are taking moment at C, we are taking this distance, this into this, and when we are taking some other moment, we want this distance. We don't want this 52.5 now. Okay, till here when we are taking bending moment at C, at that time we want finding this one also. Okay, but in this condition we are using this 52.14 and this 51.14 resolve the part C and D. Okay, now after that, what is our next step? Our next step will be small m diagram. Now draw this. Our next step will be second small m diagram. Second step will be small m diagram. Okay, now to small m diagram, m dash diagram, remove okay. Now see, now over here, see over here we want also, see this is your A part, B and C and D. Now what is the question we have asked? C. Find, calculate the horizontal displacement of roller support at D. We want D at roller support at 1 kilonewton over here. So we are applying over here, this is 1 kilonewton. Okay. Now this 1 kilonewton balance over here, this will also come directly 1 kilonewton. But here we want, here also we don't want this distance, na. When we are taking bending moment at somewhere else, we want this distance will be in the x and y direction. This is not in x and y direction with respect to C and D. So now in here also, now we have to do the same thing. We have to extend all the part whichever is possible over here, like this. Okay. Okay. Now see, now this theta you know, this theta also you know, this theta is also you know, this theta is also not, theta is nothing but 50. So theta is nothing but 59.03 degree. Okay. Now see, now we want, see this 1 kilonewton, when this 1 kilonewton is going in the this direction, means this one will going in this direction, this will come, our main will come over here is, see this one is going this direction, our main, this one will come into this one, then this is your main and this one is also your main, means we want this and this will come 1 cos theta, this is 1 sin theta. Okay, this is your small m diagram. Okay, and this is your m diagram. Okay, now see, now this will come, now here also this will come 0 because it is supported at same level. Okay, now we got this all values, this one is also, this one is also 0 because there is no load over here. Okay, now we want this L when we are taking bending moment, that we want the distance of that inclination. Now how will you find this distance? To find this distance, to find distance of C and D, apply the Pythagoras. L is equal to 5 square plus 3 square will be 5.83 meter. Our CD and our CD distance will be 5.83. Write it over here, 5.83 meter, and this is your 4 meter and this is 5 meter. Okay, now after that what will you have to do? Now we have to draw the table first. Now this is table is our third part. third part will be table, and in table we are following the bending moment sign convention is like this. Now draw the diagram. Part, then origin, limits, mu, then small mu, then ei will be constant. Okay. Now see the students, we have to solve now the table over here. Okay, in table just first take parts. Now what is your first part? Part or region, both are the same. We are taking part A and B first. Taking part A and B, origin will be A. Origin will be A. Now limit will be 0 to 5. 0 to 5. Now what about mu is nothing but M diagram. Okay, now what is this? Is your M diagram. In M diagram you are taking section over here, and this distance will be x. You are taking bending moment over here. When we are taking bending moment over here, this will 25 will come positive. 25 into this distance will be x. 25 into x. Okay, now we have come with the small m diagram. In a small m diagram, say we are taking section over here, and this distance will be x. Now we are taking bending moment over here. This will come 1 into x. Ei will be constant. Okay, now after that what will come? After your part will be, see, after that your part, we have done with the AB part. Now part B and C. Now part B and C, and origin will be C, and limit will be 0 to 4. Okay, now see, this is quite complicated over here, but see, in the basics we are taking moment over here, sorry, we are taking section over here, and this distance will be x. Okay, now we are seeing this side, not this side. Now we are seeing this side. Okay, now see, we are resolve over here this part. See, we are resolved have this part. We want this, you have to, this part you have to balance over here. Draw over here also, here only. This value will be okay. Now see, this one is also come in the picture over here. See, first of all, what is coming? See, first of all, this 52.14 is coming. 52.14. Okay, we are taking section over here. This 52.14 into 50. See, we are taking section this 52.14 into this distance, means we want this distance. This distance will be this 3 plus x, means x plus 3. So 52.14 into x plus 3. Okay, now after that this UDL also come in the picture. 30 into x by 2 minus 30 into x by 2. Okay, after that what is coming in the picture? That's it. This is also in this much is coming over here. So resolve one time over here. 52.14x plus 156.42 minus 15x square, and this is your final part. You'll resolve this part in like this. Now let's move to the small m diagram. In a small m diagram, we are taking section over here, and this distance will x, and this we want this distance. Now see, this is 0, but this is coming the picture. See over here, this 1 sin theta or 1 cos theta, this one is also coming the picture. Now see, Now in where we are taking section in this part, this will come only is coming 1. This one, no need to see this distance, please listen carefully. Don't see this 1 cos theta into this distance will be 5.83, and this also take, and this will take minus. Only we have only this 1 kilonewton over here. We this and this only applicable for C and D only. Okay, now this one will come 1 into 5 distance, force into that perpendicular distance, because we want perpendicular distance. This 1 into sine 5 is not the perpendicular distance, because we are taking bending moment over here. If we are taking 1 sine theta, the perpendicular distance will be 5.8, but we are taking moment over here, we want this distance also. That's why no need to take this 1 sine theta and 1 cos theta, only take 1 into this distance will be 5. 1 into 5, this will come positive. 1 into 5, then EI will be constant. After that, now see, now what is our next part will be, we are done with this part. See, this is a value of this, and this is the value of this, please. This is the first. Now after that, we are left part will be left C and D. C and D, part C and D. D is the origin, limit will be 0 to 5.83. Where the 5.83 is coming, this is the distance of this distance will be 5.83. you can write it over here, see 5.83. okay, now after that, see this diagram over here, take a section over here, and we want this distance is x. Now this is coming, now this one is coming in the picture, this 52.14 cos theta. See, when taking section over here and seeing this side, see this 52.14 cos theta is coming in the picture, into 52.14 cos theta into this distance will be x, coming in positive direction. 52.14 cos theta into x. Okay, this much is coming in this only, see this much is only coming. So while solve this, you got the value 52 point, it's come 26.83 into small x. This will come in the last picture. Okay, while I am resolving this one, 52.14 cos theta will come 26.83 into this x. Okay, as you all know, theta value will be 59.03. after that, we come with this picture, come with this one. Now see, now we are taking section over here, and this distance will be x. Now this one come in the picture, 1 sine theta into this distance will be x. 1 sine theta into small x. Now solve this, this will get 0.86 into x. This EI will be constant. Now we have done with this table. After that, apply the formula YD at horizontal integration 0 to L m into m upon EI into dx. Now multiplying all these things over here, take 1 upon EI constant, 0 to 5 first, 0 to 5 to 25x into 1x, 25x into 1x dx plus integration 0 to 4, 0 to 4 first bracket, 52.14 into x plus 156.42 minus 15x square. This will come in the one bracket, 1 into 5 in the another bracket dx plus integration 0 to 5.83, and this will come, see, write this one, 26.83 into x. Okay, 20.83 into x. After that, in second bracket, 0.86 into x into dx. Okay, now 1 upon EI, solve one by one. This value will be 1041.67 plus 3614 plus 1524.07. Now we get the value will be 6179.174 upon EI. Okay, now we get the value of YD will be 617.9.74 upon EI. Okay, we are done with the EI only because we don't know the value of E and I is constant. That's why we are done in the EI direction. Okay, and this is your final answer. I hope you understand my videos. Thanks for watching and subscribe the Ekeeda channel. Thank you.